I'm amazed that at a 5 o'clock slot that we have such a nice crowd out today. So we'll try to make this lively. I may end a little early, perhaps, if we'll get some good questions going on. So a couple things to get out that I hope to get out of the presentation today. First, have a little fun. But the three things that, at the end of the day, I hope that you pick up from this presentation is a little understanding of where things are from an IoT and big data perspective, how you can apply current technologies that are available to really do some good, and hopefully you get some ideas from that. And we'll look at a few new ideas as we look forward into the future of technologies you might be able to leverage when you apply IoT and big data to different business challenges, consumer challenges, or mission challenges. Just a quick correction, I am the Vice President and CTO of the Data Center Group with Intel. I used to work with Intel and McAfee and Lockheed a while back. All right, so first look at the foundation. Internet of Things and big data is really easy because someone from marketing put this single graph together and made it look really easy. We have 50 billion or more things in the world, and it's growing depending on who's funding the study. We have an amazing amount of things being generated from a storage perspective. I don't know if anybody noticed a little factoid this week. Toshiba published a new CMOS camera that does 20 meg high definition. So you figure next year sometime we'll quadruple the ability to take pictures and save. So I think that number's going to go up really quick. Multiply those together so we have the things, we have the data, and suddenly we're going to create value from everyone. Isn't this really easy? Well, of course, if it was that easy, we wouldn't have conferences like this. So with all that data that's out there, this chart on the right, and I'm not sure of the exact person who put this together, but it is an amazing eye chart. 6 months ago, this was half the size of the number of different big data or IoT companies that were emerging out there in the market. When you see a hyper growth like this of the number of startups and companies investing in an area, you know something's happening, that they think there's some great potential out there. And the great potential that's out there is what you're seeing in the lower left-hand chart is the potential of the market itself. I don't actually think the market itself is driving it from a pure dollar perspective, but today it's one of the growing markets out there that's almost creating a new renaissance in the IT and technology area that's relevant to folks that we have today. So from an Intel perspective, hopefully everybody here has heard of Intel before. We're a fairly good-sized company from Silicon Valley, been around for a while. Hopefully every time someone turns on their computer or something, you hear a cute little ding, 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 and you see Intel inside. We and others have been working in the Internet of Things for a long time. Here in the DC area, you have the intelligence community, the military community. They've been using fancy sensors for years and trying to collect that information and derive some intelligence so they could get their mission done better. But we've been pulling in new or various Internet of Things items for years. It's just recently, relatively speaking, the technology has hit an inflection point that is starting to be relevant to business, consumers, and more relevant for government in the services that they provide. From an Intel perspective, the verticals we're focused on are areas in manufacturing, industrial energy sector, the transportation sector, retail, smart home building, and that includes healthcare, and that'll be my use case study that I'll show you today. What's interesting is once you do have all this data, unless it's relevant, contextually relevant to the person who's consuming it, it doesn't have any value. From a technology perspective, we don't sell a lot of Internet of Things parts or big data technologies. We're a silicon company. But what we do try to do is create an entire ecosystem of technologies and reference designs that enables the larger industry to create solutions. So besides the instrumentation of everything you see on the left-hand side, we are putting a tremendous amount of R&D dollars across that foundation of servers, storage, networking device, new technologies in that complete area, and then trying to proliferate. We've had some big investments in Cloudera, which we think is a leader in the Hadoop space, to make it just easier. Hadoop is great technology. Forward-leaning companies have been using it for a number of years, but it's still not as easy to use as it could be. And then enable and invest in companies that give you the tools to make it easy, or easier, I don't think it will ever be truly easy, but easier to do something valuable with that data that you've now collected so you can get those applications, mostly mobile applications, in the hands of people that do something exciting with it. So there is a fair amount of this technology already. You saw that there's hundreds of little companies already and large companies already working on IoT and big data. How might you apply it? We announced this just about 2 weeks ago. I don't know if anybody else, has anybody seen any of this information about the work we're doing with IoT, wearables, and Parkinsons? I think it's pretty cool. Did someone say yes? Cool, our marketing department hit 2 people in the room. They do a really great job. In fact, a lot of the material I have today isn't just Curt's material. This is material that I pull from different teams from across Intel. So I really didn't know a lot of details about Parkinson's disease. I know Michael J. Fox had a whole foundation associated with this, but I thought it was pretty interesting when I started reading about it. 1 in 100 over age 60 has Parkinson's disease, which is a brain disorder, and about 60,000 new folks are having this disease each year. Currently, there is no actual quantifiable test that says you have the disease, which is kind of tricky. And this isn't just a US thing, this is a global thing. So it's 1 million in the US, 5 million in the world. 3 out of 5 Americans will suffer from a nervous system disease such as Parkinson's or Alzheimer's as we go forward in the future. And it's actually caused by the death of dopamine cells, and these cells are already lost by the time the motor symptoms appear. So once you know you have it, you've had it for quite a while, right? So you're just starting to see those symptoms. So I think it was Dr. James Parkinson about 200 years ago started coming up with a subjective diagnosis. And if everybody in this room knows, there's qualitative and quantitative ways of doing things. Subjectively, which is a really nice way of saying, I'm going to make an educated guess that I think you have a challenge or a disease, is probably not the way you want to approach something long term. So what could we do to harness the power of big data? Let's look at wearables, maybe throw a cloud platform in, because nobody really does anything. You got to have a cloud in there somewhere, right? An analytics program, and then how might we be able to help? Well, first, how about we put some devices to measure symptoms? Normally, what happens, a patient will go to the doctors and they pull out the charts. Maybe they have a nice mobile device and they pull out all the information, but they're just collecting it, right? And then they don't see them for 6 months or 3 months. How about we give them some measurable wearable devices that it's passive. It's really easy for them. They can measure tremors they might have, sleep patterns, their gait, which is their movements that they have through their walking and movements of their arms, their balance. Those wearable devices create about a gigabyte of data per patient per day. So you start doing your math, and there's 1 million people times a gigabyte a day. If you deployed this widespread, wow, that's a lot of data coming in, right? Sit on Hadoop, and then we're going to do some analytics for some insight. So a quick picture of some of the wearable sensors, the smartphone application that it runs on. Now what we're doing is the fidelity of the measurements that are be collected are much, much better. And it's easy. If you had to do something special every day, I don't think people are going to do it. But if you just make it easy, what happens? People use it. All right. There's actually a picture of the brain here. I'm going to get back to the brain here in a second. Let's think about the future. When I see something like this, I do work in the data center group, and I have the opportunity to work across a wide range of technologies. Big data, analytics, infrastructure, software-defined networking, cloud computing. If you were going to take technology in this particular use case example, and we get wearable technologies out there on the edge, if they're Intel, we secure them and bring them back into the big data repositories. If it's somebody else's wearables, we have secure gateways where you can aggregate that data and look at different architectures and bring all that data back as well. But you start to have some challenges. One is speed, to get information to the researchers in a timely way, and one is dealing with scale and the different types of workloads. So we're going to look into the future a little bit. First, I think about speed. Anybody actually pick up their phone or go to a website and sit there and say, wow, it took me 20 seconds to get here, so I'm just going to wait? Of course not. If you click on your smartphone and it doesn't respond really quick, you're like, what's wrong with this phone? Right? Well, Hadoop is a fantastic foundation and is maturing very quickly. A complementary technology we're seeing right now, some commercial, some open source, commercial companies like SAP, like their HANA platform, or Spark in my picture here, is actually doing all your big data work in memory. That takes a different architectural approach, different programming approaches, but the speed, it isn't just like a little bit faster, we're talking like 100x faster. So that if you're asking a question and you want to give feedback to your stakeholder, to your consumer, the difference between 1 to 2 second response time and 1 to 2 day response time, it's massive difference. So something to think about as you're going forward in the future. Hadoop is awesome technologies, but I think the in-memory, as it gets more mainstream, will complement that, and over time, you'll see the two of them converge together. Another area where I think we're taking cloud computing to the next level is if you're going to deal with this amount of scale, there's not enough humans on the planet to manually manage everything. Automation through software-defined infrastructure and having a good experience for the end user will become more and more important. And this isn't the classic cloud computing of, hey, I'm just spinning up some virtual machines. That's great, we did that 10 years ago. We're talking of orchestrating everything you're doing, adding in machine language to learn what the systems are and the applications that are running, pulling in telemetry or the data of your clouds, and then looking at things like software-defined networks, network function virtualization, software-defined storage, software-defined security, so that you can manage things at scale. One of the other things that I think will be a big difference, and I'm going to go back to the brain in 1 second. Most people, when they think cloud computing, think general compute. If I need something, I just spin up more stuff. I work for Intel. It's not a bad thing. Spin up more stuff. That's a good thing. But the reality is, these are all different types of workloads. A big data architecture based on Hadoop is a lot different architecture than you have than general computing. And high-performance computing, you know there's like a top 500 in the world of the fastest computers in the world, and they're usually like in places like Lawrence Livermore or the CERN Supercomputer Center, and they're doing this really wild, crazy stuff, and they'll ask a question, and 3 weeks later they'll get an answer. Well, one of the projects in Europe is they're mapping the human brain. If you think about like the Parkinsons information you pulled together, that may be more than a big data architecture could do. I may take some of the results of that and put it into a high-performance computing environment, and instead of waiting 3 weeks, get it back in 3 minutes or 3 seconds and get a result back that I then can apply to help someone. And that goes also now with very unique technologies. Things like, I don't know how technical we'll get, but FPGAs, where you can actually take those technologies and combine them with general purpose computing, like Xeon, and do very unique things very, very fast. And then there's, of course, custom solutions. So when we think big data, think beyond just your traditional big data where people start thinking of, I have the Internet of Things, very unique things coming out. Even Intel, we came out with this new fashion watch. I guess more people will want to wear it if your watch or your wearables look cool or something. You can buy it at Barney's or something. Your big data, which is your Hadoop and your analytics, but think a little broader of these different architectural capabilities that are out there, because I think it'll end up making an impact with the consumer or the stakeholder that you have at a higher impact than you could in any other way. Now, if you want to have some fun, use some imagination, we actually have a complete developer program. I actually picked up 2 of these kits for my kids. A long time ago, they have erector sets and Legos. This stuff is just wickedly cool. They have university programs, they have hackathons now to make it so that anybody with some imagination can start making an Internet of Things and then host it in the cloud. We have big data environments as well as software development kits that are pretty easy to use, and I think they'll improve their ease of use over time. So you can start building some very creative things. The Parkinsons example, healthcare, I think is a great opportunity that's out there, but I think we have just hit the tip of the iceberg unleashing people's imagination, especially kids. Love working with kids. They have more imagination than all the adults around here, right? Maybe they don't know how to make money on it, but they definitely have the imagination. But I have to finish with security. Don't forget cybersecurity when you are thinking about big data and IoT. The last speaker did talk about there are regulations they have to follow. Absolutely. Unfortunately, all good things sometimes are used for nefarious things or evil. Think end-to-end full lifecycle software and system engineering techniques, so when you build something, someone doesn't take advantage of it for the wrong thing. You do have to remember, whatever you're building, you're collecting all this data. The confidentiality of that data, the integrity. Someone starts changing, I can go through a list of bad scenarios, which I prefer not to, but think if someone changed the data on a healthcare diagnosis and actually on purpose gave the wrong diagnosis. That would be terrible, right? So that integrity is very important. Availability, you want that impact, privacy, and other regulations. I did leave a URL here, I don't know if just 3 weeks ago. I'm not picking on any one company, but at Black Hat's, a cybersecurity conference that's out west every summer, if it's new, someone tries to break into it. So about 3 weeks ago, I actually own one of the little Nest devices, which are really cool technology. It must be cool when Google will pay billions for your company, right? It's not based on Intel chips, but it was actually, they showed how to compromise it. So, you think, what's the big deal if somebody compromises your system in your house that does your temperatures and things of that way, because you have it all set up so that when you leave it's cool and when you're there it's hotter. Think of this as a smart meter. Actually, one of my kids pointed out, well, Dad, if someone hacked into that, they know when you're at the house, when I'm not at the house, and that's when a burglar could break in. And I'm like, well, that's pretty good thinking for a 9-year-old, right? So Internet of Things, awesome technologies, but don't forget the security, even though we can do great things with it. That's it. Thank you very much for showing up.